Hey everybody, Dr. Heldman here, Tech Talk Education. How the heck are you doing? Very nice day out here in Colorado. This is the third video in a series of videos I'm doing about creating a Linux cluster environment inside of VirtualBox VMs, a series of VMs. We have 4 so far. We have pfSense running our router and 3 Debian 12 VMs. Today what we're going to do is work on getting SSH enabled, and we'll do some cosmetic work on the VMs, and then we're ready to go ahead and start in video 4 with actually getting the cluster work going. So let's get started. This should be fun and informative. Now in front of you, you can see that I'm showing you the VMs that I already have created. So I've got pfSense here. I haven't started any of them. I'll start them in just a minute. And then I have Debian 12. This is a compute node. What is this? 1. This is compute node 2. And then I have a master node. So I've got 4 total VMs sitting out there. pfSense is running the network. It's running interference for me between my home network and this internal network, which is called cluster server. And then later on, we might add some more. We'll just have to see how it goes. But for now, what I'm going to do is get all the VMs running, and we're going to go in and do some cosmetic work on them so they're easier to recognize as you're working on them. Because when we have all 3 of them open, they all look basically the same. So we've got to figure out a way to differentiate those. Here's a problem that you have now. So if I point to the VirtualBox windows, you can see they all look pretty much alike. pfSense is really easy to see. Here's my master node, my compute node 1 and compute node 2. They all look basically alike, and then when I log in, they still look alike. So what we want to do is we want to come up with a way to supply some sort of a graphic here. Now I made this graphic in Canva, cool little computer chip there, and I neglected to bring the title down enough to where it's actually completely visible. My bad. I should go back and redesign that. But the idea is solid, because what you want to do is have a place where you can see which node you're in, and you want to be able to quickly and easily recognize that. And of course you have your host name here and some other things, but it might be better for you if you have a graphic. So you remember that we installed the VirtualBox Guest Additions, and that we enabled the clipboard. So if we say something like this, first of all, I will do a sudo apt update, ampersand sudo apt upgrade, and I'll put a tac y on that. Should be pretty current because I was working with it just yesterday, so we'll see how it goes. It's applying a few things here, not a lot. Very good. Now the next thing that we do is, you remember that we have this new command called VBoxClient, like this. Now this happens as a result of installing the guest additions, and there's this thing called tac clipboard, and what that does is that enables the clipboard. And it says down here that it's demonizing the service, which is great. We want that, but now we have shared clipboard, but we also want shared drag and drop. So the way to do that, I'll clear the screen here, is you do a VBoxClient, and you put in tac drag and drop, like that. 3 words, 1 sentence. 3 words combined into 1 word, like that. And let's see if that'll install for us. And this is demonizing the service as well. In the previous movie, what we did is we just did the clipboard. You'll have to also enable the drag and drop so that you can drag a graphic over onto the screen. So let's go look now and see what that's like. So I've already added the graphics to master node and compute node 1. I'm going to add the graphic here to compute node 2. I've also installed the VirtualBox Guest Additions. So what I will do is just enable drag and drop. So it's VBoxClient, tac drag and drop. We've got that service demonized now. One thing I would recommend to you, once you get this working this way, it's going to come back okay because you've already done all the installations and everything. But I think it makes sense that when you decide that you want to shut down the machine, like if I click this X here, to save the machine state from here on out, unless you've got something that you've done that is a mistake and you don't want to go back to that, you want to start afresh. I'm not saying that anything's going to get erased here. I think it's just better to hang on to the current state of the machine. Anyway, we have this happening now, and so let me show you what I'm going to do to get this graphic brought across. And the reason I'm doing this for you, you have to use terminal level commands to be able to get this photo copied over for you. So let me show you what that looks like. Okay, now I've created these in Canva. I'm keeping them on my hard drive over here. Here's the one I want to use for compute node 2. So I'll drag it over like that. And you see how it says copy there. What that means is that VirtualBox is fine with copying this over to Debian 12, and Debian 12 will let me bring it over. Now this is on my desktop, and so what we have to do is we have to get this into a certain place for Debian 12 to be able to see it. Let me show that to you. So if I right click and I go to desktop settings, my desktop base here, wherever this folder is at, contains all these graphics, but if I want to go look at backgrounds, that's the place where I really want to keep this wallpaper. So we're going to put the wallpaper under backgrounds. Let me show you how we're going to do that. So I'm going to cd into desktop and hit ls so that you can see that that file is out there. One thing you're going to have to be very careful about is when you create a graphic for yourself like this, one word. Don't let it be, multiple words. Don't get sucked into that, because copying and pasting, it's going to be a lot more different. I recommend that you just name this JPEG or ping or whatever one word. So in this case, it's compute node 2.ping. What I'm going to do is I'm going to move that. So I'm going to say sudo. I have to do this as sudo. Before I do that, let me show you where the files live. So I'm going to cd into user share backgrounds, like that. That's the folder that we want to take it to. If I do an ls, there's nothing in there. There's an xfce folder. We could put it in there. I'm just going to put it in backgrounds here because it's easier to get at. So what I'm going to do now is I'm going to say sudo move from /desktop/ and I'm going to move compute node 2.ping. I'm going to move that, and I'm just going to put a dot here, which means that I want to take this thing here, compute node 2, and I want to put it into the folder that I'm currently in, the directory I'm currently in. And so this dot is saying just put it right here. That's what I want to do. I want to take and put it right here. Boom, like that. Put in my password and enter. Beautiful. Now if I do an ls, first of all, you saw it disappear off the desktop over here. Second of all, it's in the user share backgrounds folder. Now you should know that when you have xfce enabled as your desktop environment, your DE, you have an xfce folder. If I change into that, xfce, and do an ls, there's some stuff in there that we could get at if we wanted to, but in this case, I want to customize this background so that we have it. Now I'm going to go home, clear the screen, right click here and enable that. I'm going to go to backgrounds, and there it is right there. I'll just accept that. There's my compute node 1. And again, the only reason I'm doing this is because as you're moving around between these things, the next section we're going to get into is enabling SSH, and you're going to have to go and experiment and make sure everybody can ping everybody and everybody can connect to everybody. It's really helpful to have a graphic on the screen that shows you which node it is that you're in and working with. So that's what we've got there. Okay, now for the SSH part. Now you remember that when we went through the Debian 12 installation video, I had you check off SSH server. We're going to have to use SSH when we're working with our clustering software. So what I'm going to do here, I just moved that, and I'm trying to get away from moving it because it goofs up me when I go back to edit the movie. Anyway, what we're going to do is we're going to check and see if that folder exists. And if I do that, I do a cd into .ssh like that. When you as a user are using SSH, a invisible folder is created for you, a hidden folder. It's called .ssh. It's not out there right now because we have not started doing our SSH work. So let me show you how we're going to handle that. I want to caution you that you want to do this as local user. Do not do this as root. If you enable SSH as root, that's great, but that means you have to be root all the time. That's really not what we want to do here. So what I'm going to do is enable SSH for my local client Bill here rather than for root. Now the command is ssh tac keygen. What does that mean? It means we're going to generate two keys. We're going to generate a private key and a public key. We're going to hang on to the private key. We're going to give the public key to the other two nodes, and we're just going to validate that that work happened. Now you have a variety of different encryption techniques that you can use here, encryption algorithms. The one that we're going to use is RSA, but there are more powerful, more potent encryption algorithms that you can use, and so that's something that you might want to think about. We might go into another movie later on in detail, but for now let's just use RSA. So it is SSH tac keygen. We'll tell it that the type of algorithm that we want to use is RSA. There are two or three others that are available to us. RSA would be the oldest one that we're using, and in the case of this cluster setup here, we're fine. If I were doing this in an enterprise class environment, I would probably pick a more powerful algorithm to do this work. But in this case, RSA is going to be just fine. So we tell it that we want to use RSA. Revest, Shamir, and Edelman, I think, is the names of the three guys that invented this. And RSA is still a company, it's still in business. And I hit enter. Now it's pointing out to you that we have a home folder here, and it's going to put the .ssh folder out there for us, and it's going to create a file called id_rsa. That is the public file, that is the private file, and it's also going to create a public file. So what we'll do here is we'll just hit enter to let it do that, boom, like that. And then what we do is it's asking for a passphrase. And if we hit enter, we'll create an empty password. In this case, we don't really care about it. And honestly, if we did apply a password, it would get in your way, because the trick now is going to be getting everybody enabled to be able to use and share SSH across this cluster. So putting a password in there means that you're going to create more work for yourself. In a production enterprise class environment, absolutely, yes, I think you need to have everything password protected. Here, where you're playing around with it, make life easier on yourself and just go with no password. So I'm going to hit enter here, and then enter again to validate that. Now you get an ASCII output here, and it's telling you that it created this key. What is it saying here? This is RSA. This is pretty big here, 372 bytes. So that's a very, very big number. And what that means is it's not as easily crackable as a lower number, like a RSA 256 or something like that. And it's using a hashing algorithm, SHA-256, to do the work. So this is really cool. This is a badge that is showing you that it did do the work. That's all it's really doing. I'll clear the screen, and I'll change into the SSH folder. So we cd into .ssh and hit enter. And if I do an ls now, you're going to see that I've got an ID RSA. This is the private key. And I've got ID RSA pub. This is the public key. And these are two different lengths. If you do an ls tac l, you can see that the private key is 2602 bytes. The public key is 569. So there is a difference between the two. What we want to do is we want to give our cluster nodes the public key. They will in turn come to us, connect with the private key, and that's how we get this secure work going in this cluster environment. Now let's see what they look like. So I'm going to cat ID_RSA. and it's a big, huge, long thing. This is 3,072 bytes of encryption algorithm here going on here. Very cool. And it's telling you that it is the OpenSSH private key. So this is good. There's no need to worry about this. It's just a great sign. This is the key you're going to keep on the masternode server. We'll clear the screen, hit the up arrow here, and we'll put a .pub on there, and you're going to notice that's quite a bit smaller. And also I would have you to note here that it says that this is Bill at masternode. That's how we know the name of the public key, who we got the public key from. And so this is really good. This means that we're ready to go. Now let's take a look at the other two selections just to make sure that we've got everything kind of set up here. So I'm going to go over to cluster node 1 and then cluster node 2 and take a look at those as well. Okay, here's compute node 1, and if I grab the terminal window here and I do a clear screen, now let's see if I can change into .ssh. Boom, no such file. Okay, now what we could do is we could run this .ssh here. We could create this, is what I'm trying to say. So it would create a private and a public key pair here. Let's go ahead and check compute node 2 and see if it has the same thing going on. And here I am in compute node 2. I'm going to cd into .ssh. No such file or directory. Okay, let's go back to compute node 1 now and see what we can do there. Or I said compute node 1, I meant master node. Let's go back to master node and see what we need to do there. So here I am in master node. We have to issue a new command here. The command is going to be, it's a new one. This is new to Linux, and I like it a lot. We used to use a command called secure copy, SCP, to do that, but they have replaced SCP with a command called SSH tac copy tac ID. And you're going to have to get used to using SSH nomenclature. So the idea is exactly like this. It's username at, and you can use an IP address or a name. Either way, if you've resolved the names using etsy hosts and you know that that works, that will work just fine for you. I actually prefer to use the IP addresses. So I'm going to say that I want to SSH copy ID to Bill at, and then I type in compute node 1's address, 192.168.1.1.3, and hit enter. Now what you get here is it's coming up and it's saying, hey, you know what, I'm going to go ahead and copy this. Are you sure you want to continue connecting? So what's happening here is it's seeing that SSH is running on compute node 1, but there's nothing there yet, which is fine with us. We don't really need a private key sitting on SSH on a compute node 1. What we want is the public key just copied over to there. So what I'm going to do is just type in the word yes and hit enter. And then it asks me for my password on 192.168.1.3. Now this is the reason I wanted you to make them all the same, because it's going to make life easier for you unless you decide that you want to keep a list of passwords and things like that. Okay, now it says we should try logging into the machine using this. So just to make sure that we can get in. So let's see if we can do this. So I'm going to say SSH bill at 192.168.1.3 and hit enter. And notice here, guys, that I am now in compute node 1. So my old prompt was master node right here, but now it's telling me that I am in compute node 1. So that is very good. That's exactly what we want to see. We want to be able to see that we are able to natively connect to compute node 1 without any passwords. And again, I want to say, if I were doing this in an enterprise class production environment, I would implement passwords and I would go through the battle of making sure all the passwords are working. And you would have to do that. You can imagine if it was 1,000 nodes rather than just 2 compute nodes, that might get a little problematic, and that's where DevOps comes in, and we'll go down that road later, much later on. Okay, so to get out of here now, I'm currently Bill at compute node 1. What I want to do is get out of here and go back to master node. You type in exit like that and hit enter, and now I'm back at master node, and I'm still in the .ssh folder. We're going to rinse and repeat that command here. So I'm going to put this into compute node 2 now and hit enter. Again, we get presented with this idea here that we're going to share this. It's saying it can't be established. Key fingerprint SHA-256. This key is not known. Are you sure you want to continue connecting? Yes, I do want to continue connecting. Hit enter. And then I have to type in my password again. And there we are. Now we're in. And notice here that it says now I'm in compute node 2. So that's a great thing. So that's all working. What I would do now, if I were you, we should try doing SSH bill at 192.168.1.4 just to make sure we can get in. Beautiful. Now we're in compute node 2. We're in there. Everything's working. That's all good. I'm going to exit out of here, clear the screen here, CD enter, and clear the screen. We're back to normal here. Let's go over to compute node 1 and make sure that we can SSH into master node. Alright, so here I am in compute node 1. I'm going to type in SSH bill at. You can try a name here. If it fails, you just got to resolve the names. You could check and make sure your names are keyed in. This is something that I would do if I was, I had a little tablet and I'm going through and I'm just making sure that everything's level set. You could cat etc host just to make sure that those are keyed in. Look at that, I don't have them in there. Let's go edit etc hosts. So I'm going to say sudo nano, we have to be root to be able to do this, /etc/hosts. I'm going to type in my password. We're in nano here, and here's how you do this. So you say 192.168.1.1 is pfSense. I'm hitting my tab key to get that little bit of space in between there. 192.168.1.2 is master node. 192.168.1.3 is compute node 1. And 192.168.1.4 is compute node 2. And you got to make sure the spelling's correct. Everything looks correct. Control O and enter to save. Control X. We're out of there. Clear the screen. Let's see if we can ping master node. Boom. Beautiful. That's working great. Let's see if we can SSH into master node by name. SSH into bill at master node. Boom. Oh, I get presented with this fingerprint thing here. That's fine. I type in yes, I do want to connect to you. I type in my master node password and hit enter, and good deal. Notice here that I am in master node now. That is an awesome thing. I love that a lot. And that tells me now that this communication network is set up. I will exit to get out of master node. You've got to remember to watch these things here to be able to tell which machine you're into when you're SSHing into something. To get out of the SSH session, you type in the word exit, and we're good to go there. Let's go over to compute node 2 and see if that is set up. Alrighty, here's compute node 2. I will cat etc hosts and see if that's set up. Yep, I did set that one up. I put all those in there. That's a beautiful thing. Let me see if I can ping by name. So ping pfSense. And the idea here is you already know you can ping them because you ping them by IP address. Now we're just seeing if we can resolve the names, if it makes sense for us to be able to resolve them by name. It's not super critical. You can use everything using IP addresses. But I kind of like knowing that we can use the names as well. And then node 2. That's a great thing. Clear the screen. Okay, so let's SSH into bill at master node. It says, oh, do you want to continue? Yes, I do. Type in yes. And I'm going to put in my welcome one. Bang, password here. And there we are. I'm back in master node again. That all looks very good. And I type in exit. Now I'm back in compute node 2. Now what just happened? Well, let's go into .ssh and take a look. ls. Now I want you to see here that you have a new folder that was created for you called known hosts. and you've got an old one called known hosts old. I don't really care about that. I might remove it later, but I'll keep it for now. Let's cat known hosts, like so, boom, and take a look at that. Now we've got a key in here of some kind. That means that we have connected to master node, so we're in good shape there. We can go over to compute node 1 and check the same thing. Here I am at compute node 1, cd into .ssh, ls, there's authorized keys and known hosts. Now I don't have an authorized keys here. I didn't have an authorized keys in compute node 2. Why do I have that here? Well, because when I did the SSH copy ID over to this box, it took my public key from master node and copied it to compute node 1. So if I do a cat on this, cat authorized keys, and hit enter, notice here that this is the master node public key. It's in a folder called authorized keys, meaning you are authorized on compute node 1 to connect to master node. Now compute node 2 is not quite there yet, so let's go fix that. We'll jump back to, this is confusing, I know, that's why I'm going through this. We'll jump back to master node, issue our SSH ID copy command, then go back to compute node 2 and make sure that it did indeed receive the public key. Alright, so here I am in master node. I'm going to cd into .ssh. I don't need to do that. I'm going to say SSH tac copy tac ID. Again, please remember you're doing this as you, not as root. And I'm going to do this to bill at 192.168.1.4. That is compute node 2. I could try doing it with using compute node 2 instead, because that using names makes it easier. Hint enter. Oh, it sees it out there. It's prompting me, do you want to do this? Yes, I want to do this. Hit enter. There we go. And it says compute node 2's password. This is why I wanted you to standardize on that password. Beautiful. Now it says try logging into the machine. Okay, let's do that. SSH bill at compute node 2. Enter. That's a great thing. That's working. Exit. Let's go back to compute node 2 and see if that file got copied over. So here I am in compute node 2. I do an ls, clear the screen. Lo and behold, authorized keys is out there now. Authorized keys. And again, it is the public key for master node. Now we're set up. We've got SSH working. We've got name resolution working. We've got IP resolution working. All of the nodes can talk to each other. This is a very good thing. And now what we're ready to do is dive into the next movie, which is where we actually get going on installing the clustering software that we're going to use for this. It's called MPI. And as well, we might even get to the point where we can write a piece of code to validate that these nodes are working. So thanks for hanging in with me on this. I know there's a lot of complexity to this. That's why I wanted to go through this, because I want to tell you and communicate with you that your Linux Plus certification, maybe your Linux Professional Institute, I think it's Linux Professional Institute certification, LPI, those certs are very good. If you wanted to get into the gig of being a Linux server administrator, lots of room for you in the world. Honestly, the world runs on Linux, guys. I know it runs. Windows AD is a great thing. I use Windows 11. I know a lot about AD. I love that. But at the end of the day, the world is running on Linux servers. So if you're liking these videos, please tell your friends about it. I am trying to actively grow the channel. And subscribe. Tell your friends about it. Have it ring you when there's a new video that's out there, and you're welcome to drop some comments if you'd like. That's all perfectly acceptable. I get some really good comments from you guys, so thank you for that. And I will talk to you in the next video. Have a super duper good day. Talk to you soon. Bye bye.